For the second chapter of this mini-course, let's turn our attention to how R2-D2 authenticates Obi-Wan Kenobi. I'm going to assume that R2's memory has not been wiped, and also that R2 is not in fact a Force-using droid. Now, it's obvious no one ever enters a password, but more, it's obvious that R2 has a depth-sensing camera, because it's used to record the holographic message. It's reasonable to use it for authentication, and in a way, R2 has the components needed for Face ID just like an iPhone. Also, that camera and display are shockingly better than the weapon targeting systems in the Millennium Falcon. Now, it's a bit different than Face ID because it works after nearly 20 years. Over 20 years, bones change. It turns out they change in predictable ways, and R2 has had a day or so to figure out how aging might impact his now old friend. The trickiness is that most biometric systems don't store raw information about things like bone structure. They process that raw data into what's called a template. It's a model, optimized so a new scan can be quickly compared to the template. And so R2 probably has to go back to memories of Obi-Wan, compute aging functions, and then generate a new template for use. Alternately, R2 could use the template with a much lower threshold for matching than would normally be used. Most biometric systems can be tuned in these ways, and so increasing the acceptable false accept rate might allow an older Obi-Wan to authenticate. Now, authenticating humans to computers is a complex task. When we make demands that serve the technology, like use a long passphrase, they can be unreasonable. Perhaps he's forgotten it over 20 years. Great engineering focuses on the needs. In this case, delivering a crucial message to an old ally. Extra credit number 2. Show the access control rule Princess Leia writes and explain how R2 parses it and what dependencies it has.